have worked with 5 engineering firms in the past 12 weeks about agentic workflows and how to cut their drawing time so as to increase their output and their revenue. Despite being from different industries like civil, structural, mechanical, process equipment, building services, all of them had these gaps which were sort of universal. And I think if you are running an engineering firm and your drawing output isn't where it needs to be, there's a good chance you are sitting in one of these in your business right now. So in this video, I want to walk through 3 of them, what they are, what happens if you don't fix it, most importantly, how do you fix it? Hi, I'm Vignesh, founder of Vistrux. I help engineering firms cut their draw time and increase their revenue by building agentic AI drafting systems. The first gap that I see in almost every firm, and nobody really has a name for it, but I assure you, you have felt it. Every time you start a new job, you manually edit project names, your job number, sheet number, etc., and spend 5 minutes just figuring out where everything is. That's the difference between structured and unstructured drawing data. Even if you use the find and replace tool, it still won't cut it. There is a hidden problem, and I'll explain it in a minute. Well, Vignesh, can you explain structured versus unstructured data a bit more? In most small to mid-sized firms, when a drafter sets up a drawing, everything is just a raw text, like project name typed somewhere in the title block, your revision number typed somewhere else, your scale, date, drafter name, all manually entered. At this stage, your each new job is sort of like a blank state, though you could be copying details, but all the time that you saved in copying those details went into checking. That's unstructured data. And the problem is nothing is enforcing consistency. Drafter forgets to update the revision, it doesn't get updated. Puts a scale in the wrong format, it goes out wrong. Someone new picks up the drawing and doesn't know your conventions and they guess. Now, you might be asking, okay, Vignesh, what happens if I don't fix it? Well, here it goes. The checking never stops because there's no structure underneath the drawing. The only quality control is your senior engineer reading every element on every sheet. Now, senior engineers are not cheap. They are expensive. You know it already. You don't need some guy on the YouTube saying, hey, your senior engineer is expensive. You know it because you are paying them. And on top of that, it scales badly. More drawings means more checking, not less. It also means you can't automate anything. Now let me just give you a simple example here, okay? Imagine I hand you a stack of index cards with my beautiful handwritten notes scattered across them. FYI, my handwriting is not that bad. Anyway, all these index cards, it's just my text. There's like no labels or no grouping or anything. If I ask you to find the project name, what would you do? You would take all of my index cards, you're going to read all of it. Now that's exactly what AI has to do with an unstructured AutoCAD drawing. It scans through every text element, tries to figure out where the project name might be. And because it's guessing, the reliability drops. Now imagine those same cards. Now what I did was, along with my beautiful handwriting, I put in these color-coded tabs in different colors. And one could mean, okay, this is where the project name is. This is where the revision is. This is where the dimensions are. Now when I ask you to look into something, you go straight to what you need. If you're going straight to what you need, so will code, so will the AI. It becomes easy for it to look at it as well. So let me show you how to, this is like a very simple one, how to structure your data. And what I mean by that, if you look at, say, your AutoCAD, okay? Now I've got like few other examples here. These are like fields. I'm just going to show you how you can create your own field. So let's just say I need another one here within my title block where I want to add the name of the contractor. Okay, let it be ABC Contracting. Now, usually what people do is they would create either like a simple block or something, and they copy that block onto different viewport, sorry, on different layouts. We don't necessarily have to do that. And this is what I mean by structuring the data. Now, let's just say if you are trying to put AI on top of this, what happens is Agentic AI would come in, extract all the text field in this drawing, and try to find, okay, this is AB, trying to find the name of the contractor, and would go like, okay, I need to change the name of the contractor to some ABC Contracting. What would it do? It would try to read each and every text in there. This is like an empty template, but imagine when you have like a lot of drawing data in, it would be very difficult. What in order to get over that, and this is not necessarily just for contracting or just adding one text, you can expand it into many other things, by the way. But this is just an example. So you can think about what you can do as well. Let me get into it. Okay, now I want to always add a, thing here, which is ABC Contracting, the name of the contractor. What I'm going to do is I'm going to go to the option here, go to Drawing Utilities. I'm going to go to Drawing Properties. Here it is. And right now I've got these fields. These are custom fields. You can go to this General, Summary, Statistics, Custom. So you need to go to the Custom tab. And what you're going to do is you're going to add. You're going to add contract the contractor's name, and you're gonna go ABC Contracting. Okay, for now I'm gonna click OK. Okay, now you're gonna go to the text field. Now you Control A and then you do Control F. You can do Control F or right click and then go to, you can go to Insert Field, and then you come here, go to Document, and then you can find contractor's name. And I needed an uppercase, and I'm gonna put uppercase. That's it. ABC Contracting. The idea here is, in this whole drawing, you're going to have many typical notes and everything, and you're going to say, hey, refer to the contractor or something like that, or refer to the architect. What you can do is insert this field in as architect's name or say contractor's name. What happens is at that point, all you have to do is go to this field here, Drawing Properties, and then you change from whatever name you want to ABC Contracting to double contractors. You regen double contractors. That's it. And your entire drawing changes. Now, this is different from what you would see from, let's just say, um, like simply plugging in AI, because what would end up happening is AI would have to extract all that data and then go ahead and change it. It's fuzzy logic. You can't be, it's sort of like how you would do it too. So there's no reliability there. Whereas if when you're using this, all AI has to do is put in a function, hey, wherever there's this, just for this function, contractor's name, put this value, and it would change it. That's it. Um, this is like a very simple explanation of custom fields. The second one is a little bit uncomfortable, okay? Because as much as it applies to your principal and your senior engineer, it applies to the drafter as well. One of the questions that I ask every firm that I work with is, can you describe your exact workflow from the moment you receive a brief to the moment a drawing goes out the door, step by step? In 99% of these cases, almost nobody can. I mean, it's so interesting, right? Like, you have been doing this for years. You know how it works. It lives in your head. It feels so obvious, but it's never been written down, which means it's never been transferred. Your drafter is working from a partial picture. They have picked up bits and pieces over time, watched how you do things, filled in the gaps themselves. But there's no source of truth, no documented process, no way to know whether what they're doing actually matches what you want. I totally empathize with you here. I was in such a boat and it feels overwhelming. There's like so many things that you have to do, and this doesn't look like a priority. I know that actually. I really do. The way how I think is this, okay? If your most experienced person left tomorrow, how long would it take the next person to figure out how things are supposed to work? That is that is just your workflow visibility score. For most firms out there, the honest answer could be in months. Oh, I bet you'll be thinking, Vignesh, can you really tell me what happens if I don't fix it? For that, here it goes. Like it or not, agentic AI is coming. Maybe you are already thinking about it. Maybe you're not there yet, but it is coming. And when you start automating, the first question you have to answer is, which workflow do I automate first? And if you don't have visibility over your workflow, you are guessing. I've seen this happen, and despite my warnings to you guys, I know like few people who reached out, and this has been my warning. Like, I know I posted this video which barely got any views, but that's fine. I actually talk about the importance of understanding your workflow first. And despite all of that, a firm picks up a workflow, throws money at building it out, and it doesn't move the needle. The drawings might not come out faster. Your team would still be under all these pressure. And the conclusion they reach is AI doesn't work. Please, please listen to this. AI is not the problem. I assure you, it's not. Please listen to this. Picking the wrong workflow is the problem. And you pick up the wrong workflow when you actually don't know where your time is going. Without that workflow visibility, you cannot make that call confidently. You are spending real money based on your gut feeling. And if it doesn't pay off, you have just given yourself a reason to write the whole freaking thing off. Now, the question, Vignesh, okay, how do I fix it? I'm pretty sure, just like those people, you might listen to my video, you might look into my videos, you're like, oh, okay, you know what, I'm going to do this, I'm going to bring in real value to my company, and still not do this, and you're going to complain. But that's okay. That's going to be a lesson, and you might come back to this video again. I want to keep this video as short as I can, but what I have done is a full video on this, how to map your workflow step by step, how to identify where the right automations actually are, and how to calculate the ROI before you spend a single cent. Also, the extra revenue which you unlock when you automate it. Links in the description. There's also a free tool to get you started, by the way. If you do this work once, the sort of clarity you get on the other side, knowing exactly where your time is going and where agentic AI can take it off your plate, is worth every hour you put into it. And the third one. This is the one with the most untapped potential for engineering firms. It is the usage of dynamic blocks. Most AutoCAD users know dynamic blocks exist. A lot of firms even have some. But in practice, what I see is either no usage or basic usage. Maybe a block with few visibility states, maybe a stretch action. That's it. What I don't see, and this is where the real potential is, firms using dynamic blocks to actually encode their design logic. Vignesh, tell me what it means. Okay. Think about your most common drawing type, structural connection or your vessel detail. a drainage schematic, or whatever it is. Within that drawing type, there's a set of variables, dimensions that change, parameters that depend on the design inputs, edge cases where the standard detail doesn't quite apply. Right now, your drafter handles all of that manually. They look at that sketch, interpret the variables, redraw the geometry. A well-built dynamic block encodes those variables directly. The drafter inputs the dimensions. The block handles the geometry, connections, annotations, callouts, or whatever extent that you go to, and everything that follows deterministically from those inputs. And once you have built in these standard variations your team handles regularly, those don't require a decision anymore. They are already in the block. Now, the main question, okay, what happens if I don't fix it? Without this, every drawing of the same type is a manual rebuild. Most likely your drafter is spending time on, moving things, redrawing things, checking dimensions, instead of on actual design decisions. And because it's manual, the output varies. The same connection looks differently depending on who drew it and when. That inconsistency feeds straight into your checking load. Vignesh, how to fix it? The starting point, let it not be like a dynamic block itself. Let the starting point be mapping out the variables. Take your most common drawing type and ask what actually changes between one instance and the next. Write down those variables, the dimensions, your parameters, your design inputs. Then ask what are the standard variations? What are the 5 or 10 edge cases your team handles regularly? Once you have that list, you have the specification for your dynamic block. You know what it needs to handle. Your drafter inputs the variables, block handles the execution. Output is consistent every time. Let me show you an example with the dynamic blocks as well so you understand. I Okay, this is like an example of a pad footing. Okay. This is like a very primitive version, so you can understand what I'm talking about. And I'm still working on it, but you would get the gist from this. Okay. Now there's pad footing. Okay, there's the PF1. If you want to change it, you would double click it and you just change from PF1 to PF2 or whatever that is, and then you go on to different one. You go the one with a single PA, where if you have like a board PA1, if you double click on it, then you would see okay, there's pad footing 2, BP1, or if you have other types, you can name them. And now you go to another one when you have two Ps, and then you can change the what do you say, the position of where these pairs are and the size of the footing over here. Edge distance 1, this is right now 500. This can be like 350. See, as you can see, it moved 350. Now you can change the length and width. For example, PF length is, I don't know, 2500. So as you can see, it moved. So this is like a simple example, and I've got like other versions as well, like for 3Ps, for 4Ps. So you can see this. This is a if you're familiar with Revit, if you know how Revit works, you'd know, you'd sort of understand how this thing works. This is very similar to Revit's family functionality. This is just so you see it in action, because one thing that I've seen in my content is people would like to see it in action and understand, and sort of try to sink it in. This is not 100%. I'm still working on it, and I would soon put it out. Okay, let me just bring it all together. Let's take this home. Okay. So there are three gaps. One is the unstructured drawing data. Two is no workflow visibility. Three is dynamic blocks sitting there underused. And I want to show you how they actually connect, because in isolation, each one is worth fixing, But when you fix all three, something else becomes possible. Here's a real example. A pad footing detail. A simple enough drawing, but your team does it constantly. If your title block has custom attributes like project name, drawing number, revision, all structured and in the right place, that's topic one done. Your data has a home, as you have seen. If you have mapped your workflow and you know exactly what inputs drive that footing detail, it could be like your width, depth, reinforcement, that's topic two. You know what to automate and why. If those variables live inside a dynamic block, so the drafter inputs the dimensions and the block handles the geometry, that's topic three. The execution is systemized. Now, if we wire it together and a simple script which says insert this block, set these attributes to these values, then you put a cloud skill on top, its only job is orchestration. You describe what you want, the skill calls the code calls the block updates, and the drawing's done. I want to give you a real number here because I'm not exaggerating when I say this. I was doing this comparison between like a pure AI workflow and the agentic workflow. Okay. And the client requested the first one. Usually I wouldn't do it, but then he's like, he had this affinity towards it. So I wanted to show him, hey, you know what? It could work, but let's look at why this is better. And what happened was the opportunity, what he wanted to look at, it would sort of consume like 10,564 tokens. And the agentic workflows that I was working only consumed 860 tokens. 860. I'm not exaggerating at all. That's like a 91% reduction. Let me tell you one more thing. I actually didn't notice it. It was my client who noticed it, and I because the first one time when I told him, I'm like, hey, it's like 10,564 tokens. And then when I was showing him the sample of our agentic workflow, he's the one who saw it. He's like, oh, that's only like 860 tokens. I'm like, yeah. Now you might be thinking, why does that matter? Because no matter where AI pricing goes, if your workflow only needs a few hundred tokens, you can stay competitive. AI can still handle the judgment and orchestration. Code handles repeatable execution. Dynamic blocks handles the geometry. And in this case, nobody's doing the other person's job. What we are essentially doing here is we are going to use the best of AutoCAD, we are going to use best of code, and we are going to use best of AI.